Grade 11, let's cover a Euclidean question together. Now this question it's a very good question for beginners. It is very useful and helpful for those who are incredibly stressed over Euclidean geometry, outrageously terrified of Euclidean geometry. Now this is a good question that will alleviate and sedate those feelings of stress and anxiety. Why is that? Well, that's because this question, it's pretty straightforward, not a lot going on. You're not going to be intimidated while approaching a question like this. And so what you want to do is you want to watch very carefully, you want to take notes, and also if you would like the actual PDF version, or all the PDF version of all the other questions that we've been covering on this channel, what you need to do is you need to send in emails. The email is in the description below, or you could just comment. You could just leave a message in the comment. And also, if you found this video helpful, consider leaving a comment and consider liking. Consider also hitting the notification bell. And without further ado, let's get started. Now we have 9.2. The points S, Q, R, and P lie on the circumference of the circle with center O. SR bisects chord PQ at M. PR and RQ are joined. R1 equals to 62 degrees. Now, the very first thing that you want to do is, if there's any mention of the center, you just want to write down a few of the ideas and concepts that we associate with a center. Okay, so we think of radii, we think of diameters, we think of angle at center twice as much as angle at circumference, and what else do we think of? We think of radius, and we also think of line from center to midpoint of chord, which is it goes unnoticed. It goes unnoticed all the time. So now let's start off with the radii. We want to identify our radii. Now a radius is a line that stems from the center and touches the circumference of a circle. Okay, and all radii in a circle are equal to each other. So we know that OR is a radius and OS is a radius. It stems from the center and touches the circumference of the circle. Okay, so what does that mean? That means OR is equal to OS, since all radii in a circle are equal to each other. Now, those are all the radii. Now, upon completing the identification process of select, or after you've identified all your radii, what you want to do is you immediately want to identify your diameter, right? Now, a diameter is a line that crosses through your center, resulting in it touching both ends or both sides of the circumference of the circle. Now, we can clearly see that RS is a diameter. Now, what does that mean? That means that RS will subtend a 90-degree angle. And so what you want to do is you want to take your pencil and trace the lines from both ends of the diameter, trace it back to the other end of the circumference of the circle. So we trace this line, it ends right over here at Q1. Do the exact same thing on the other side, trace the line, it ends right over here at Q2. Now the angles between these two lines that I've highlighted, these two yellow lines, we can see that we have Q1 and Q2. Q1 and Q2 are between. Okay, they are between the two yellow lines. And so Q1 and Q2 will equal to 90 degrees. Very easy method that you can apply. It's very easily applicable. So we know that Q1 plus Q2 is equal to 90 degrees. And now what we want to do is want to continue on. So we've identified our radius and we've identified a diameter. What about angle at center twice as much as angle at circumference? Now this theorem over here is it's only applicable to a question in which you'd have your center that is partitioned into different parts. And so what that means is your center has to be made up of different parts. It has to be divided into different sections. So what that means is you'd need to have O1, O2, O3. It needs to be divided into different parts. However, in this question, that's not the case. We just have O. We just have center, a solid line. It's not partitioned. It's not divided into different sections. No, we just have O. Okay? And so we definitely know that angle at center twice as much as angle at circumference is not applicable to this question. So we don't even have to elaborate. I don't even have to elaborate on that. I don't even have to continue on with that now. So now let's go on to line from center to midpoint of chord. Now, what does this theorem entail? Why is it important to understand? So now what the entire idea of the theorem of angle at center twice as much as angle at circumference is that the line that stems from the center and touches a chord, resulting in that chord being split into two equal parts, or it could be the alternative, where you'd have the line from the center to the midpoint of the chord, and the angle between that line and the chord is 90 degrees. So it can be either way. Okay, so it can be either way. Okay, And so let's identify, and by the way, the line from the center is not your radius. It's not the same thing. Not the same thing. So what we want to do is we want to identify the line. So line OM. So we can see that we have line OM, and OM touches chord PQ. We have to understand what a chord is. It's very important. Students don't even know what a chord is. Okay, a chord is a line that slices out, it carves out a certain section of the circle. It carves out a certain section, resulting in a segment being formed. And so this carved out part of the circle is our section. And the only way that that carved out part is created is through the is by our chord carving it out. Okay, and so PQ is obviously a chord. It's not a radius, it's not a diameter. No, we're not going to confuse, we're not going to conflate those two ideas. No, we're not going to do that. Okay, so PQ is a chord, and we have line OM. OM is not a radius because it doesn't extend all the way to the circumference of the circle. This is important to remember. This is important to remember. This is the basis. These are basic ideas. Okay, these are just the basic ideas. Okay, so we have OM stems from the center, and then it touches the chord PQ. But now it can't just touch chord, PQ. It needs to have touched PQ, and that chord PQ needs to have two equal parts. And how do we know that? Well, we can clearly see that PM, it's made up of PM and MQ, and PM and MQ are equal to each other. So we definitely know that line from center to midpoint of chord will be applicable to this part, to this question. Why is that? Because we have line OM. Now OM touches PQ, and PQ is split into two equal parts. So we definitely know that line from center to midpoint of chord will be applicable. And so what you want to do is you just want to annotate a 90-degree angle onto our diagram. So that means this part of M will equal to 90 degrees. Also M2, by the way, M2 will equal to 90 degrees, M1 will equal to 90 degrees. Just this entire section over here, this intersection, the intersection at which OM bisects and cuts through PQ, resulting in PQ being bisected. So when a line bisects another line, what it means is that it cuts it into two equal parts, resulting in the line that cuts through that line to be perpendicular to the other line. Okay, and so we know that M2, M1, this entire part is 90 degrees. M2 is 90 degrees, M1 is 90 degrees. This part is also 90 degrees. And let's continue on. Okay, so we've identified all the theorems, we've annotated our diagram accordingly, according to those theorems. We've used that as criteria. This is our little criteria that we've set up for ourselves. Okay, and so let's continue on. Calculate with reasons the values of the following angles. But before we continue on, a lot of students forget this. We need to identify a cyclic quad. So we need to see if there's a cyclic quad that is present in this specific diagram. You see, and this is something they're not always going to outline in the segment above. Okay, so cyclic quad. So what you want to do is you want to look for a bow tie shape, or you could just look for a four-sided shape that touches, in which all four of its sides touches the circumference of the circle. You can clearly see a bow tie shape, right? So you can see P, we've identified a bow tie shape, so that's bow tie, highlighted that in blue. Okay, so that means P and S are in the same segment, meaning that P and S are equal to each other. Okay, so P and S are equal to each other because of angles in the same segment. Please ensure that you use corresponding colors. SR1 equals to Q2 because of angles in the same segment. And you also want to make sure that you look at it from a horizontal perspective. So maybe if there was an additional line over here connecting both P and S, then you could say that P equals to R2, and then you could also say Q1 equals to S, but that's not the case. So so then we're just going to end it over there. Now let's continue on. 9.2.1, we have to calculate the values of M2, the value of M2. So now M2, just like I've said previously, M2 is equal to 90 degrees because of line from center to midpoint of chord. Want to write that down, M2 equals to 90 degrees because of line from center to midpoint of chord. So you need to substantiate your answer by providing a statement, by providing an appropriate statement. Okay. And so let's continue with the next question, 9.2.2. What is Q1 plus Q2? Now that's very obvious. This is so obvious. We've annotated that onto the diagram. So the little yellow rectangular block represents a 90-degree angle. And why is that? Well, we said that Q1 plus Q2 is equal to 90 degrees because of angles in a semicircle. Remember, we've identified a diameter, which is RS. RS subtends a 90-degree angle. Okay, so what you want to do is you want to go back and you're going to substantiate your answer. You want to verify the fact that q1 plus q2 equals to 90 degrees because of angles in a semicircle. So that's very, very straightforward. Okay, now let's continue on with 9.2.3. S. What is the value of S? Now, before we get started, you need to first identify the angles that S is equal to directly. With any, generic Euclidean geometrical theorems like tan chord, angles in the same segment, etc. So we can see that we've marked off S and P with the exact same color, and so we've connected the two as being equal to each other. Why is that? Well, because we said that S equals to P because of angles in the same segment. We have a little issue. We know that S equals to P, but P does not have a numerical value. We don't know P's value. So now, what do we do? We need to approach this with strategy. We need to approach this in a very strategic manner. Okay, and so what you want to do is you want to identify any other angle that's equal to P through any Euclidean theorems, tan chord. No, you can clearly see that we haven't marked off P as being equal to any other angle. And so the next thing that you want to do is you want to draw on your knowledge of angles in the same segment, exterior angle of a triangle. You want to think of these geometrical theorems, so important. So the very first thing is I do suggest that you start off by using sum of angles of a triangle and identifying the triangle that P is a part of. Now, P is a part of several triangles. It's a part of triangle PRQ. It's a part of triangle PRM, but we have to, we obviously have to choose the triangle that has the most information. And so if we look closely at triangle PRM has two angles that already have values. We know that R1 is 62 degrees and we know that M2 is 90 degrees. And so we could easily just use sum of angles of a triangle to calculate what P is equal to. And so what you want to do is you want to take 62 plus 90 degrees. Okay, 62 plus 90 degrees plus P equals to 180 degrees. Please don't forget to provide an appropriate statement following your answer. And once we take all the values over on the other side of the triangle, well, you first have to state the fact that S equals to P, which equals, anyway. So anyways, after using sum of angles of a triangle, once you've calculated everything, you've taken everything over on the other side, final answer will be 28 degrees. Because of sum of angles of a triangle, they use a different statement, but just use sum of angles of a triangle if you're familiar with that. And so now we've calculated the value of 28, and then you have to go back, connect the dots. And so if P equals to 28 degrees, we know that S will equal to 28 degrees because of some angles in the same segment. And that's exactly how easy it is. Okay, everyone. Thank you for watching this video. I definitely do encourage everyone to watch this video over again, and if you would like to access the PDF version of these questions, do consider, or please be sure to send an email, or you could just leave a comment just leave a message in the comment down below. And also, we are hosting sessions in preparation for your final exams, grade 11s. I know that a lot of the matrics steal the attention, but we got you covered. We are also very dedicated to your progress in your math journey until your exam. Okay, and so what you should send an email to the email that is in the description below, or you could leave a comment. But without further ado, we will see in the next video.